tell me, am I audible or not? Today we are going to discuss stack, one of the important data structure in DSA, and first of all we will see what is the stack, and then we will see its representation, and then we will do its implementation part. Okay, so hi, this is Sharda from GoEduHub Technologies, and I'm going to discuss stack in detail today. So guys, please confirm me, am I audible or not? And I would like to wish you all of you Merry Christmas. Okay, so I got some confirmation. Now I'm going to start this. First of all, what is the stack? You can see here one diagram. Stack is ordered collection of homogeneous data elements. Like we have seen some other data structures, like we have already seen array and linked list. Now we are going to see one more data structure, that is the linear data structure, that is the stack, and it's very important. Okay, like what the real-time use case? If we are using a stack in the data structure, how could be beneficiary? Like I'm using this website www.goeduhub.com, and what I can do, I can read even, I can go to this hot menu, I can go to universities, and from the universities I can pick any university, and then I can go to some labs, like I can go to the data structure lab, either I can go for the Python lab, like this. So what I just want to tell you here, a browser is maintaining a history. I just want to go back, like what I have previously visited, which page I have opened last. So this is basically managing history. Okay, when I press the back button, it will show me the last page that I visited. And then again, if I'll press this back button, it will show me the previous page that I have visited before this page. So just imagine, if you are a browser developer, how would you manage this history in terms of data structure? Like I'm visiting one page, then another page, then another page. And if I click on the back button, I'm going to the last page that I visited. Okay? So basically, I'm traversing links in backward order. So there would be different options, like how I can maintain those links. I can maintain those links with the help of array, right? And you know, array, basically in the Python, we simply implement with the help of generally a list or with the help of array module. So I can use array to store all these links. I can use an array that will store first home page, then hot links, then you can say universities. Okay, something like this. Okay, and it is storing all the links in order which I have visited. So if I want to access, I just want to go back, I can take the last one. Okay. Next option can be, we have seen linked list. Okay. Next option can be linked list. There can be links like first page, and then second page, and then third page, like this. You can use linked list, and list basically it is storing every link, and we are connecting with the help of this link address. So you just want to access the last, then you have to go from the first, then second, and then third. You have to visit all 3 nodes, then only you will get the last link. So using linked list, you have to traverse the linked list till the end, and then end will give you the last link. Every time you have to do the same thing. Okay, so this is the problem with the linked list. Order of n time it will take to pick order of n time. Similarly, if I talk about the array, I can pick easily the last element a of 2. But there is the problem with the arrays. As I already told you, we have to use the dynamic arrays. We have to use the dynamic array, and you know, because we cannot fix how much links I can visit. Okay, it's increasing dynamically. And there are the such issues with the dynamic array is like memory reallocation. I already told you, like if my array have capacity of 5 elements and I just want to insert the 6th element in memory, then it will go to the some other place, copying all the elements. Okay, so what we need to do, we will have certain overheads there. So in this situation, we want a data structure where what we want last link which we have inserted last, we can pick that one first. A link, you keep on pushing the elements to the particular data structure, and then you click on the back button, you retrieve the last element that you have pushed. Okay? So similarly, we have third data structure. I can say stack. Stack is generally used to maintain the history of browsers. One of the example of this. Okay? What happens in the stack? Stack works in the order of like last element you have pushed, you can pop that first. So let me open new page and I can tell you, and here we will take the stack. Okay, what happens in the stack? Initially we will insert home. Okay, and then if you have one more, then you can insert home and then hot. Okay, and similarly you can insert first you visited home, then you visited hot, then you visited universities. Now you just want to go back, then what happens? You can pick last one, that is the universities, and then you can pick previous of it is hot, and then you can pick home. So whatever the links you have visited, it's pushing the elements to that particular order. And then when you click over the back button, you retrieve the last element that you pushed. So what we are doing here we are doing last in, first out. Or you can say first in, last out. Two things we can say. Stack is working over this concept. where you keep pushing the elements, and when you say pop, it will pop out the last element that you have pushed. You can take an example, like you have a rack of, like in your kitchen, you have a stack of dishes. So when you just want to pick the first dish, then you will pick the last one which someone put it there. Okay, you will be picking up the last dish. Okay, clear till now what is the stack? Guys, can you please give me a quick confirmation? How does it works? Are you getting the things? Then I'll go to the complexity part. Okay, in the complexity part, what we are doing here, basically you can say there are the certain limitations with this array and linked list if you want to do the operation like this. And let me write here complexity. You can say me how much time it will take. If I talk about the push and pop operation, it will take order of n. Order of 1. And similarly, if I want to search an element, then it will take order of n. If I talk about the array, in array I want to search an element, then I need to run 2 loops. So that will take order of n square. In the worst case. And here the search element is taking only order of n. Okay? And when we are using the stack, generally we are using the stack like in the programming language. If I talk about the programming language, stack is generally maintaining the function calling. Like in the recursion, what happens? We call one function again and again. So we are maintaining the order in a stack. Like main function, then our search function. Okay, and then some inside the search we are again calling the search function. So basically we are picking like this. And another application you can see, like you are using either Word or you are using the Paint. I just want to do certain works as a undo. Control Z. Undo functionality in any editor uses stack to track down the last set of operations. How we can implement the stack? We can implement the stack, like here we are going to implement a stack with the help of Python. So with the help of the Python, there are the certain ways in the Python we want to implement the stack. So there is one way is we can implement the stack with the help of list. Another way we can implement the stack with the help of, there is a collection called DQ. And there is a collection Q, LIFO, Q. We can use either of any. But as I told you, list, with the list, it won't work. It will take the more time and it is not efficient. And we generally opt for the collection DQ. Okay? Let me come to back to the article. Here we have an article, we have put it in the description of this video, and you can see we will go through certain theoretical part that generally we should know about the stack. Okay, and like what the operations we can do in the stack and what are the things basically about the stack, some advantages, some disadvantages. So we will see that. Okay. So here you can see stack is a collection, ordered collection of homogeneous data elements where the insertion and deletion operation occurs only at one end that we call the top of the stack. Whatever we are doing with the help of top of the stack. Okay? Like we just want to do the push, we can do with the help of top of the stack, and if we want to do the pop, then we also do with the help of the top of the stack. Okay, and stack is a linear data structure as we have array and linked list. Collect the homogeneous data items to perform the insertion and deletion at one end only called the top that I told you already. Now representation of the stack. To implement the stack principle using arrays and linked list. We can implement a stack with the help of array and linked list. We will do the implementation part in the Python. Just wait. I'm coming to the code part. We will do the implementation. Okay. And it follows the last in first out. We know that array representation we will see, and by using the fixed size of array to perform the stack operations. And to perform the collection of data elements dynamically by using the linked list with the help of, these are the certain representation we will do. Operations, what we can do, here only the 3, I can tell you the 4 operations. Like one is the push, that is the insertion, and second operation you can say the pop. Pop means we just want to remove the items. Delete the topmost element of the stack. And how much complexity it takes? Order of 1. And push is insertion. Push is insertion. We just want to insert the element, adding the element at the top of the stack. This also takes the order of 1. Pop also take the order of 1. And similarly status. Status we just want to know like either my stack is empty or not. So if I'll check the empty, then I can use the empty function. It will return the true and false, either a stack is empty or not. This is also order of 1. If I want to search some element in the stack, then it will take order of n. And I can find out the size of the stack. I can find out the position of the top. So except the search, all other operations are taking order of 1 time complexity. Okay. Push operations, this is the simple algorithm. I don't want to go there. What we will do, we will start and then we start the pushing the element. If a stack is full, then we will come out of this. Similarly, for the pop, we are accessing the elements. We are removing the elements from the stack, and if our stack is empty, then we will stop. Okay, and status, we want to check it out, either a stack is empty, stack is full, and position of the top. Some applications of the stack, you can say what two application I already told you, and some others you can say evaluation of arithmetic expression, like here we will do the infix to postfix, postfix to infix, and prefix. These evaluation of mathematical expressions we can do with the help of a stack easily. And then code generation for stack machine, and then implementation of recursion I already told you, and record management if you want to do the, like you just want to track back, and reversing a list of items and backtracking. This is one of the way, and decimal to binary conversion. These are the certain applications of the stack. Okay. Expression I'm not going to solve right now. I just want to go to the implementation part of the stack. Okay. So we just want to do the implementation, and inside the implementation we are going to do the 4 operations: push, pop, pick, and is empty. Okay. So let me open the Google Colab, and I'm going to see how we can implement the stack. Okay. You guys also do along with me. Okay guys, did you get the concept of a stack? What is the stack and how does it works? And you should know certain real-time applications like I told you. Okay, so first of all, I just want to implement the stack with the help of list. Simple. Okay, or you can say stack implementation using arrays. And how we are implementing arrays? We are implementing arrays with the help of a list. So here I'm going to implement stack using a list, and here I'm taking a stack empty stack, and then inside this stack I'm going to append certain elements. S dot append, and here I'm going to write, suppose I just want to append A, and S dot append B, S dot append C, and one more I'm taking S dot append D. Okay, I'm just appending certain elements to the S. Muthu is asking, ma'am, what about the circularly linked list? That is the simple concept. It is similar to the doubly linked list, and today I'll tell you certain questions so you guys can solve by yourself. If you are still facing any problem in linked list, then we can take the questions in another class. Okay? S is equal to empty, and then I'm appending 4 elements to this. Now what I want to do, I just want to do the certain push and pop operations. Okay, so inside the list we have certain functions like append is for adding the elements. Okay, and then we have one function called the pop, s.pop, and this will remove the last element. So last element what we have added, D. Similarly, s.pop okay, it's removing C. I can print S, and you can see now my S having 2 values. It is pop is printing the element as well as it's removing the elements. If I don't want to remove, I just want to see the element at particular location, like last element I just want to print, then we know how to access the last element in the list, S of -1. Okay. Now the issue with using a list as a stack is that list uses dynamic arrays internally. So when it reaches its capacity, it will reallocate a big chunk of memory somewhere else in memory area and copy all the elements. For example, I can say, I already told you, I think this concept I told you so many times. Again, I'll tell you one more time. What happens, my list having capacity of 6, or you can say my list having, these are the certain gray area, these are not belong to this, 1, 10, 20, 30. My list having capacity of 3, just I'm taking a small capacity, you can take like 5, 10, okay, and it is dynamically allocated memory. Initially, dynamically allocate some memory in the compiler, by the compiler in the memory area, in the RAM. So basically what happens when you want to insert the 4th element, then it will shift all the elements to a new memory area. 10, 20, 30, and here we can insert the fourth element 40. And the new memory area will assign the capacity that is the previously we have for the list and some double of this capacity. Like here we have capacity of 3, then we can say 3 and 6 more. So 9 capacity will be assigned. There is the certain formula internally they are following, like 9 capacity for the dynamic list will be assigned. Again, if I try to insert 10th element, then it will allocate memory space somewhere else. So what we need to do, we need to copy all the elements to some other place. So here the overhead creates. Two things we need to follow: allocate the new memory plus copy all the existing elements in the new memory area. So that's why we are not opting for the list to implement the stack. Okay. So we are going to implement the stack by using the another method, that is basically, let me go back, using the DQ. Come here. One way is implementing with the help of the list. Another way is implementing with the help of collection DQ. So collection DQ is more better than the list. You can go to here and you can Google what is the collection DQ and go to the Python documentation. Where is this one? And here you can see collection DQ. It's not showing. Where is this one? DQ objects. DQ objects returns a new DQ object initialized left to right. Append data at the end. And DQs are generalization of stacks and queues. DQ supports thread-safe, memory-efficient appends and pops from either side of the DQ with approximately the same order of 1 performance in either direction. Okay? And here inside this DQ we have certain functions. Like we have append function to add to the right, and we have append left to add to the left. We are not going to use this function because we are implementing the queue. That's why we are going to use the append function only. Somebody is asking a question, ma'am, if memory is pre-allocated in the stack, which means it is the wasting of memory, why am I do this? It's not pre-allocated. I'm telling you that how you can implement the stack. If you are implementing the stack with the help of the list, then it is wastage of memory. It creates some overheads. In the queue, in the stack, I'm not telling you it's pre-allocated. Stack we are going to implement with the help of DQ collection. And Muthu is asking, ma'am, here we are implementing using libraries, so no need to write logic. Yeah, there are the certain functions already available, so we can use those functions. But like I'll tell you certain interview questions, when you are going to solve those questions, you have to apply your logic. Okay? Basically, one part I have told you, like simple thing. implementation of stack, this list using list. So this program I told you, what we are taking here, we are taking empty stack, then we are appending, we are inserting, we are pushing some elements, and then we are printing our stack. After that, using this pop function, we are like popping out the elements. So this is the simple implementation with the help of the list, and it has certain limitation that I told you about the memory allocation and some overhead it's create when we are allocating the new memory. Internal working I have told you. Okay, now we are leaving this part and we are going to implement with the help of this DQ collection. Okay, we are not going to implement with the help of list, we are going to implement with the help of DQ. Like I can tell you, using DQ as a stack, okay, from collections, import DQ. Okay, and from DQ I'm initializing the stack equals to DQ. This time I'm taking the empty stack with the help of this. Now you can see what the functions I can apply over the stack. I can apply different functions with the help of dir. I can check stack, and it will tell you lots of operations and functions I can apply over this stack. Append, append left, clear, copy, count. The functions we have seen here all are the same. Okay, so dir is directory, it's telling all the properties which a particular stack having, all the functions, all the elements, whatever we can use with this stack, that it is a list. Like here we are getting a list of all the functionality that we have inside this stack. Now what I will do here, I can write like this, stack. Here also I can use append function, append, and then I'm writing a, okay, and then I'm printing stack. You can see DQ having a, one element. Similarly, stack dot append, it's not a list, b. Now I'll print stack. Okay, 2 times I have run this stack dot append, that's why it's taking. Otherwise I'll run this again, this one, and then this one. Now you can see we have 2 elements. Similarly, we can append more elements. Stack dot append C, stack dot append D, okay, and stack. Now my stack having 4 elements. You can append as many elements you want. Okay, now I'll pop the elements stack using the pop function. Here also we have pop function, stack dot pop D. We have popped D. Now you can print the stack. You can see we have only 3 elements A, B, C. Similarly, you can pop stack dot pop. One more element I have popped. I'm running this stack dot pop stack dot pop. Now you can print the stack and you can say this is the empty. Again, if I'll try to pop out one more time, then you can see pop from empty DQ. Okay? Getting, guys? Now what I will do, one more thing, here I can implement this using a class also. This is the simple thing, I have written the comments directly. Now same program I can implement with the help of class also. So I can say okay, implement a stack with class. You can simply write here a class stack, okay, and inside this class I can define a constructor in it, because when we are going to solve certain difficult question, we are going to use with the help of class only. Okay, so here what I can write, self dot stack, I'm taking a variable stack, equals to DQ. Collection I have already imported. So here I'm taking the DQ. So it will initialize the stack with the DQ, means empty DQ. Okay. And now I'm going to define some more functions, like for the push, I'm just defining one function called self, comma, data. And then here I'm going to write self dot stack dot append, and I can write data. Okay. Similarly, I can define another function for popping the element, like def pop, and here I can write self, I don't need to pass element, it will remove the last element. So self, it will return, I can directly return self dot stack dot pop, right? And similarly, I can define one function peak for getting the current top, self, and here I can return self dot stack or last element -1. Okay. Similarly, I can define one more function for checking it's empty or not, is empty self, and inside this I can return length of self dot stack equals to 0. Okay. I can define one more to getting the size of this, one more function called size self, and how I can get the size, return, and then I can get the length of self dot stack. Okay, this is class I have defined, simple class. I have defined certain functions. Now what I will do, I will initialize an object of this class. Here I'm giving capital S because my variable name is also same. Okay, so this is capital S stack, this is name of the class. Now I'm going to initialize an object of this class S equals to stack. Okay, and then what I will do, S dot push some value, like 50. Okay. And then what I will check, s dot is empty. You can see the output is false because we have one element. If I'll pop out s dot pop, okay, 50 is popped out, and now I'll check either s is empty or not. Then it's true. Now I'll push certain items like s dot push 10, s dot push 20, s dot push 30. Or one more I can take, s dot push 40. Okay. And then I can check the peak of this. S dot peak. Peak is last element. What is the last element? Last element is 40. Similarly, I can pop s dot pop. You can see last element. I can pop all the elements until it is empty. So s dot pop 30, s dot pop 20, s dot pop 10, and then if I'll try one more time, then there would be error, like pop from an empty DQ. Getting the things? What I have done? I have written a class. Muthu is asking a question, ma'am, could you please code the complete logic for push and pop without libraries? We don't need to write without libraries. Here we have lots of functions. We have to use those functions. Then only you can work perfectly. There is no other way to write the without using the functions. That is very difficult logic code, and you don't need to do that. You can use the list then, and you without writing the function, inbuilt function, you have to write the loops there. And we want minimum, we want the minimum complexity. So if I talk about push and pop complexity is order of 1 only. Here I'm not writing any loop. Okay. So I hope you guys get the, again I'll revise the complete program. You can see from here, like what we are doing from collections, we are importing the DQ, and then inside the stack class, we are defining certain functions. And then we are creating an object of this stack class, and then we are doing certain operations. Yeah, this is the logic, Muthu. If companies are asking the logic, then it is the same logic. They never ask logic for the pop. They will ask what you are doing in the stack. They will ask certain question where you have to recognize how to implement the stack. How to you will do, how to pop and how to push. Okay. Like I'll give you certain interview questions. You can see those questions, and then you will ask me again the things. Okay. This is the simple implementation part. Same thing you can do with the help of like linked list we have done, and using the DQ we have done, and one more thing we can do with the help of linked list also. That is the simple part. Like if I want to do the stack implementation with the help of linked list, Arrays part we have done two ways with the arrays, simple using the list and then with the help of the functions. That is the simple thing. We can define our functions. This you can see from this in notes. And stack implementation using linked list. This is the simple part. Here we are implementing stack in the form of linked list. So I hope you know the linked list. By seeing this code, you can understand the things. This is your task. Guys, please go through this code and hopefully you will get, because I have explained each and everything. So this is the simple part. In the linked list, we need to create the node, and then inside we are creating a class called the stack, and here we are pushing the elements either, or we are popping the element. Just we are setting our head. Okay. Now there are the certain questions. Like what type of questions will come in the interviews? If you go in a good company's interview like Google, Microsoft, Flipkart, if I talk about the good companies, then you can see they always ask some problems that are related to either a stack, linked list, heap, other data structures. What you need to do there, you need to recognize the parent question. Like the basic question is what? In the stack, what you can do? You can do the push, you can do the pop, and you can get the empty stack, you can get the size of the stack, you can get the top of the stack. Okay, and whatever we are doing here, we are doing with the help of order of one complexity. Now I can tell you one thing. Let me open. Like how we are recognizing a problem is related to stack, or can we solve that with the help of stack or not? Okay, like I'm talking about the interviews, some interview questions. Top companies. Like if you are sitting for a interview, or even in the coding round for a company like Flipkart or Amazon, Google, then you will face the problems like this. Like one question I'm providing you, simple question, nearest next largest, find the next largest element. Or you can say nearest greater to right. What is actually problem? What is the question here? Here we have an array, you can say one, 2, 3 and 4. We have 4 elements. Now what we want in the output, basically we want an array that is the next largest element. Next largest element. What is the next largest element here? If I talk about the 1. Okay, if I talk about the 1, then I will see all the elements that are the right to the 1, and the elements that are right to the 1, then the highest element that is near to 1, like the value that is greater than 1 or near to 1. So you can say here 2, or I can change the values, like in place of linear order array, I'll pick the array value change like 1, and then here I'm picking 3, and then 2, and then 4. Okay, this is the simple example. I changed the example, and now I want a output. Like what output I want? Here if I talk about the 1, then the largest element that is next to 1. You can say we have 3. Okay. Similarly, if I talk about the 3, then the largest element that is near to 3 is 4. If I talk about the 2, then largest element near to 2 is 4. And if I talk about the 4, then there is no more elements, then we will return -1. This is the output I want. Now you have to solve this question. You have to solve this question simply in the minimum time complexity. One more example I'll take here. A array I'm taking here 1, 4, and then you can say 2, 2, and then 0, and then 1, and then 5. Now this is my array. What I will do here? First, for this I'll put -1. Okay? Because for the last element I want the maximum, -1, sorry. And then if I talk about the 1, then for the 1, largest nearest value is 4. If I talk about the 4, then largest value, then 4 is 5. If I talk about, then the largest value for 2 is 5. For next 2 is also 5. For 0 is 1. For 1 is 5 and -1. I want this output. I'm an ordinary student. What I will do? I will write a loop. You know the brute force, simple brute force. In the brute force, what we will do? We will write a loop. Like this question you are getting, what you will do? You will write a loop. Like here, I'm writing a loop for int I equals to 0. Okay. And then I'm taking I less than length of my array. And then I plus plus. Simple, I'm not taking a load about the language. I'm just writing a simple loop. This is loop for traversing. And then what we need to do, like here I have taken one example of 1, 3 and 2, 4, this array. So first time I need to pick first element. And then I have to traverse all the elements that are the right to this first element. So what I will do here, I'll write one more loop, j, and then I'll start j is equal to I plus 1. And j, I'll go till the less than the length. And then j plus plus. Here I'll write 2 loops. And then inside this, I'll write certain condition. I'm not going about the what condition we will write. But basically, I'll write a loop. And these 2 loops will take the complexity of order of n square. Okay. Same question. I can solve with the help of a stack also. And with the order of n complexity. So basically in the interview what they want to solve this question with the minimum time complexity. So 90% people will solve this question with the help of this type of approach. That is the brute force approach. But it is not optimized. If interviewer will ask you, write in the minimum time complexity. Then you have to think about this, like what approach I can apply. So whenever there is a condition, like we are writing multiple loops and loops are related to, like j is dependent on I. When j is somehow related to I, then we can solve this type of question with the help of a stack also. how I can solve with the help of a stack. Okay. Now what I will do, initially I'll take a empty stack. Okay. And like first element, if I talk about the first element is 1. Okay. And I'll pick the first element, and then what I will do, I will put all the remaining elements in my stack. Okay. And I'm not putting all the elements, like I put the first element initially. And then I'll compare my element is x, that is the 1. My element is x, that is the 1. If this top of the stack is greater than this x, then I can say this is the greater right value. So I'll put 3 here and I'll pop out this 3 from the stack. Okay. After that, I'll move towards the next element. If I talk about the next element 3, then again now my stack is empty. I'll put here 2 and I'll compare. 2 is less than 3? Like 2 is greater than 3? No. Then I'll go to the next element and I'll put that element into the stack. And then again I'll compare. If 4 is greater than 3, obviously 4 is greater than 3. So I'll put this value here and I'll pop out this 4. I'll remove this 4. Let me take another example. You guys are getting the things what I want to tell you. Okay. Hemant has written like largest element near to 3 should be 2. No, near to 3 should be 4. The element that is greater than the 3. Like again I'm taking 1, 3, 2, 4, and then you can say here I can take 5 and here I can take 2. This is the array I'm taking. And output should be, what the output should be here? You know, for the 1 output should be 3, and for the 3 it's a 4, and for the 2 it's a 4, and for the 4 we have 5, and then 5 we don't have greater than element. So we can put here -1, and for the last also -1. Okay, Hemant got it. Okay. Or initially I'll take the condition like this only, like if it is in place of 1, 2, it's a 12. So what happened here? Here we will put 12. First I'll explain you the simple thing. 4, 3, 4, 4, 5, 12, -1. This would be the output. Okay. And how I can implement the stack? First thing, first you need to recognize the problem. Like I'm given a problem, I just want to get the maximum, like nearest largest to the right. So I just want to this, then how I can apply the stack? First thing, simply using the loop. I told you we have to write 2 loops here. We need to take first loop for I and then second loop for checking remaining array. Okay. Similarly for the next element also, first this and then for the second loop is for this. This is the simple approach. And you can say 2 variable I and j. J is dependent on the I. That type of problem you can solve with the help of the stack in the time of order of n complexity. Okay. How we can solve? Like here initially x we are taking 1. And then we are taking a stack, and inside this stack we are putting the values. Okay, inside the stack initially we are putting value 3, and we will check either 3 is top of the stack is greater than this value. Yes, it is the greater than this value. Then we will keep it here, and we pop out this value. We remove this value. Then we will go to the next value, and that is the 3. And for 3 also we start the values in the stack, and initially we will put 2. 2 is greater than 3? No. Then we will put the next value 4. 4 is greater than 3? Yes, 4 is greater than 3. So we will keep 4 here. And we pop out this 4. So now in my stack only value is 2. Okay. And next we will go x is equal to 2. And now what we will check? For the next element is 4. We put the 4 here, and then we will check top of the stack is greater than this or not. Yes, it is greater than this. So we will put here 4 and we pop out. Okay. Similarly, for the next value, that is the 4, we push the 5. And 5, obviously it's greater than, then we pop out this. And if x is equal to 5, we will check, there would be the 12, and x equals to 12, and our stack is empty, last element, so we will put the -1. We can solve this problem with the help of the stack in the order of n complexity. There are the lots of questions that we can solve. Yeah, nearest right. We just want to find out the nearest right. Question is basically I have told you question. Nearest greater to the left, or you can call it next largest element. Next largest element, nearest greater to right, you can call any of them. So we have lots of problems like nearest greater to left. Similarly, we can do nearest greater to right, nearest smaller to left, nearest smaller to right. All these are the similar kind of problems. Guys, can you please give me a quick confirmation? Are you getting the things? Now, what I just want to tell you, what we need to do, we need to find out the parent problem, how we can solve this problem, how we can relate the stack in this problem. Like we can solve this problem using simply by 2 loops also. Okay. We can write the 2 loops and then we can write the condition. But the same approach, we can do same question we can solve with the stack with the order of n complexity. Shall I need to write the program? Basically, we are getting the things like I just want to tell you how to recognize the problem. If you recognize the parent problem, and always if you think there is some problem that you can solve with the 2 loops, and in the second loop variable is related to dependent on the first loop, then you can say you can solve that problem with the help of the stack easily, and it will take the less time. How to identify that we can apply stack in particular problem? That is the question. You need to think about it. Like whenever you are getting a problem, you need to first think about it. How I can solve this? and then like identify if there I can apply an array. It may be I can solve this question with the help of array, so I can solve this question with the help of a stack also. Try to apply the stack. Like what type of loops we can have here, I can write here conditions, possible conditions, like what we can two loops. We can have two loops, okay, and one loop can be I equals to 0 to n, and second loop can be j equals to 0 to n. Here dependent j is dependent on I. Like how can it possible? J can be 0 to I, or you can say j can be 0 to like I to 0, I to 0. It means j is decreasing, here j is increasing, okay, and there would be some other patterns like j is I to n, then I can say j plus plus, and if j is n to I, then I can say j minus minus. This kind of conditions, the dependency of j can be like this. J is basically depending on the I. Okay, so whenever you are looking at two loops question, then just try to implement array question, just try to implement the stack, and it will take the less time complexity. Okay, people are asking for, ma'am, please write the program for this. Okay, I'll write the program for this, don't worry. Okay, let me open the Google Colab. If you understand the concept, if you identify the parent problem, like how can I solve the problem, then you can simply solve the problem. Any difficult problem you can solve. Okay, so what the steps we can use? First, we will push the first element to the stack and then pick the rest of the elements one by one, and inside the from the stack we will pick the first element, and then we will compare this first element with all the remaining elements. Okay, let me write the program, you will understand more clearly. Problem is next greater element to write. Similar there would be four problem. Next greater element to the left, next smaller element to the left, and next smaller element to the right. These four problems are interconnected. If you solve one problem, then you can solve other problems also. Okay, so here what we will do, first we will write a like we import DQ from collections. Okay, what I have written, just a second, from collections import DQ. Okay, and now I'll define def, I'll just want to define a stack. Okay, Or either I can use my last program. I have written that class program. I'll use this one, okay? In this, what I'm doing, initially I'm creating a stack, okay? A empty stack. And I'm taking empty stack and I have written here push and pop operations. Okay? Now I'll write one more function. Okay? Here I'll write one more function. Def print next greater element. You can give any name. And here I need to pass the element, that is the data. Okay? Self comma data. Okay? So here first I'll creating a stack. So for creating the stack, what I'm doing here, I'm calling this. Or my stack is created when I call this s equals to stack. Okay? So my stack is created. Now what I will do here, I'm taking a variable initially self dot next equals to 0. And then here I'm pushing element like push function. I can call the push function self.push data. Okay? Then I'll iterate the remaining elements. Okay? Iterate rest elements. Okay? Here I'm writing a for loop for I in range of 1 comma length of s. Length I have written already, na? Size. Self dot size. Comma 1. Or I can write this. And here what I am doing here, self dot next equals to I'm assigning the elements of this stack. Let me take some questions. Can we use a stack? Just I'll write the program. Just wait, guys. First, I'll answer certain question. Can we use a stack for printing patterns? And ma'am, please write it using loops. You can do any question in which I and j is related. You can do with the help of the stack also. So patterns you can do with the help of the stack with the minimum time. But pattern is not a logic. Pattern is just like you simply printing something. Nothing else you are doing in the print pattern. Pattern is just clearing your logics. And Rohan is asking, ma'am, please write it using loops. I told you, for using the loops, you simply write the function. Like I can tell you. Rough idea I can give you. I cannot write the program for everything. I can give you the logic. You guys please try after the class. Like here, for 2 loops, what you can do, you will write first loop for first loop you will write from I to length, and then second loop you will run from for j to j is I plus 1 to length, and then you need to check it out if a of I is less than a of j. Then my next is a of j, and I'll break it. Simple. If it is greater than this, then I'll pick that, put it inside the next, and I'll break it. This is the simple logic, and same thing we can do with the help of the stack. For the stack I need to write a little bit more, but and I need to write, I cannot accommodate in this program, I need to write it separately. Just wait. Like def stack, I'll define the stack initially, and here I'm taking s is equal to, simple stack I'm defining here, s is equal to q. Okay, dq. S is equal to dq. I'm defining this, and then I'll return s. Okay, this is simple for creating a stack. And then I'm checking def is empty. Just wait guys. I'm passing here s, and then here I'm return length of stack. Length of s equals to 0. And similarly I'll write one function for push s comma, I can take x. I'm not using here the classes, I'm simply writing. Okay, so s dot append x, and then def, I'm defining the pop equals to s. Okay, and here I need to check if is empty, is underscore empty stack. Then what I'll print? I'll print empty, otherwise else I'll return s dot pop. Okay, now I'll write one function for this. Def next for next greater ge. Okay, I'm writing one function. And here I'm passing an array. You can say array or you can say a stack. Okay. Now what I will do, s equals to, I'll call my first function, that is the stack. So this is for creating the stack. This will create a stack, and here I'm taking a variable next equals to 0. And then I'm writing here a loop. First I'll push if a single element, push the first element to the stack. This is the logic, push the first element to the stack. S and the first element, whatever I am getting, because here we are getting an array. We are not getting a single element. We are getting an array. So what we will do, we will create a stack, empty stack, initially S, and then first element of this array we are pushing to this S. Okay. So I'm writing here array of 0. First element I have pushed here, and now I'll write a loop for remaining elements. Okay. For I in range, you can say, and here we will start from first and we will go till the length of array. Okay. And then here we are assigning next equals to array of I. Okay. And if this array is empty, this stack is empty, the stack I have created, if this stack is empty, then I'll keep another variable, and stack is not empty, then until we will put the next element, and we are checking here a condition if element is this next is greater than the top of the stack or not. We are checking a condition here, next is greater than the top of the stack or not. Getting the things? Guys, can you please tell me, are you getting the things till now? Everything is clear or not? Like here we are going to write a condition while we need to take one more variable, e equals to 0, and then here we need to put e equals to top of s, we are taking top of s. This element is for the top, you can say top, or you can say top of the s we are popping, and then what we are doing here, top is less than next. We run this loop until top is less than next. We print here element. So we can convert, element can be a string, element can be an integer. So basically we are converting to the string so that we will see the representation here. So top, and then I'm writing here a concatenating a string simple, and then next of it, str of next. Both element we are printing, top and next. We are seeing what is the value inside the top and what is the value inside the next. If my S is empty, my stack is empty. If my stack is empty, then what I will do here? I'll break the loop. What the function I have written for the empty is underscore empty. And my stack is empty as, then I can break the loop. True. I can say there is no element. Otherwise, element this top equals to pop S. Okay, this is the loop, and one more condition we can write here. If this top is greater than next, then we will push S comma top. Okay guys, these are the things I need to write. Little bit confusing. To push value into the stack from array, we have to use loop only, ma'am. We are using only one loop that is running till the end. It's only the comparing. This never runs n times. This is not the dependent rule, a loop. Like we run only this n times, we never run this n times. Just try after the class this program. You will see the difference. You can manually check each and everything. In the stack, it only takes the time of order of n. You can understand by the logic also. Here we are only comparing the things. Like I have removed that part, but here we are only comparing the things. We are using the same stack. One time we are putting all these things in a loop. We are not running this 2n times. Here what is somebody is asking, ma'am, please explain this function one more time. Basically what we are doing here, we are iterating the loop, and then the remaining elements in the stack, we are putting the elements in the stack, And sometimes what happen if our stack is empty? Let me write here. What we are doing here, just try to understand here. Initially, we are taking an empty stack. Okay, empty stack we are taking, and then what we are doing, we are pushing first element to stack. Okay, this is the one step, and in the step 2 we are iterating rest of the elements. So here we are applying a for loop, and that starts from 1 to n, and first element array of 0 we are pushing into the stack. Okay, and then if here inside this loop we are writing certain conditions, we have to write certain condition. If our stack is not empty, then we pop an element from a stack. Okay, one condition we have to write this: if our stack is not empty, and if popped element is smaller than the next, like whatever we are popping, if popped element is smaller than next, whatever we are having, we don't want this one. Popped element is smaller than the next element, then we will print simply pair, and we are keeping popping while elements are smaller and a stack is not empty. Keep smaller until stack is not empty. And second case is what we need to take: if element is greater, top of the stack is greater, then what we will do? We will push back to the stack. And we got the element. Only these things, and one condition we need to write for the last element, like after iterating over the loop, there are the certain elements who don't have greater. For those we need to write -1. So loop is this loop, in the second step we are running one loop only, and that is n time. Searching the element in the stack, it will take only the order of n time. Okay, just try after the class, and then we will discuss one more time in the next class. Don't worry about it. If you getting the confusion, just try after the class. If you are still getting the confusion, then I'll explain you one more time in the next class. Just give you the quick recap. Right now I have provided only the logic. You have to try it once. Okay, I think this is enough for today. We have discussed the concept of the stack, and then we have implemented the stack in the Python with the different ways, like with the help of linked list and with the help of DQ, and then we have discussed one interview question, that how you can approach the stack. Okay guys, can you please give me a quick confirmation, are you getting the things or not? And still, if you have any question, you can ask me in the next class. Okay, I think this is enough. We have already taken the more time than the this class. Bit confusion is there, well, try after the class. Okay, yeah, sure, try after the class, because it is the programming. I can tell you only the concept. How can you understand the programming? If you do one time by your hand, using your hands, then only you will get the things. I can tell you the concept only. Okay, okay guys, thank you so much. This is enough for today.